Okay, question 7. This one is talking about a person riding a motorcycle and they're doing a wheelie, and they're saying that someone that can do a wheelie can do more than 320 kilometers. And let's look at a particular example. Let's get right into it. Let's talk about that the positive direction is the direction of the motorcycle. Easy. Let's have a look at our information inside. So that's saying that before he does his wheelie, his initial velocity, let's do that in U, his initial velocity is 8 meters per second. Okay, before he starts speeding up, then he starts to accelerating at 2.00 meters per second, and the person travels, we'll do displacement as red. So we'll do the person travels, displaces themselves for 40 meters. So in this particular problem, sorry, I had a bit of a blank there. This particular problem, we have U, 8 meters, acceleration 2, displacement S, and we want to know how fast he is going after doing all that over 40 meters. So our V equals, we don't know, and it's going to be in meters per second. So we're going to use a different equation this time because we're not given time, we're given how far he goes, but this time we don't actually need time. So this particular equation is quite useful if you're not given time. If you're just given how long, how far they go, and you're given their acceleration, so you can work out some of the other ones. So let's plug in the values. Our v squared we don't know, so let's put our v squared as white. So our v squared we actually don't know it. Our u squared we can already do it, but if we're going to square the whole term, I'm also going to square the units as well. So 8 squared is already 64. 8 8 is 64. So if we square the units as well, meters squared, squaring that just multiplies that exponent. So that'll be meters squared to the second to the negative 2. We add that to, so that's a plus 2as. We multiply that by 2 times our acceleration, which is let's get rid of this. Let's already multiply our acceleration by 2. So if we were accelerating at 2 meters per second, let's already multiply that. So we are accelerating at 4 meters per second and multiply that by our displacement, which is 40 meters. If we do this, 40 times 40 times 4 is 160, and if we multiply meters by meters, it's meters squared times second to the negative 2. And if you notice here, we have like terms here. We have like terms. Even the units are like. So what do we do? If we add these two like terms, because they're like terms, 64 plus 160 is, I believe, 224. So that should equal 224. Is that correct, Mr. Kuhn? (224 meters squared to the seconds to the negative 2. Okay, sorry about that. I was just checking my math. I think my math works out. So 64 plus 160 should be 224 meters squared by seconds to the negative 2. So that's a negative 2. If we square root that, and I'm going to separate I'm going to separate each term. So if we square root 224, and what happens if we square root meters squared and seconds to the -2? Okay, we know this is about 14.97, that value, square root of 224. What happens to this value if we square root a squared? Basically that becomes a 1. So whenever you square root an exponent like that, you divide it by 2. So 2 divided by 2 is 1, so that becomes m. -2 divided by 2 is -1, and oh my gosh, look at that, we become meters per second. So our final velocity, so sorry, over here I sort of skipped a step, I apologize. If we square root both sides, because remember here we have v squared, we get v, and that's our final velocity, and that is our problem solved. So hopefully that was useful for you.